Dear MTN students, welcome back and good day to all of you. This is an AI voice-over of your lecture with Dr. Abdullah. I will begin by explaining the outline of this recorded session for Chapter 1 of System Administration. Simply put, this course we are starting is intended for those who want to learn the Linux operating system and master some of its technical aspects. It does not assume any prior knowledge of Linux. Also, the chapters and the quizzes introduced are geared toward systems administration using Linux systems. For our Chapter 1, it will discuss an introduction to Linux. We are going to introduce its operating systems as well as the features, benefits, and uses of the Linux operating system. This chapter also discusses the history and development of Linux and open source software. The main objectives of the course are listed in the slide. It includes operating systems in general, the Linux operating system, history of Linux, Linux common uses, and finally we conclude with Chapter Quiz 1. For the first objective, we are going to discuss on the operating systems. Any computer is based on an operating system. This operating system manages all of the software and hardware on the computer. Most of the time, there are several different computer programs running at the same time, and they all need to access your computer's central processing unit, CPU, memory, and storage. The operating system coordinates all of this to make sure each program gets what it needs. Also, as seen from the slide, there are many operating systems from different vendors like Windows 7, Windows 10, Linux, Fedora, Mac, Android, and many more. Every computer has two fundamental types of components, hardware and software. Hardware consists of the physical components inside a computer that are electrical in nature. They contain a series of circuits that are used to manipulate the flow of information. A computer can contain many different pieces of hardware, like processor, physical memory, hard disk, removable flash media drives, CD/DVD, sound cards, video cards. Software, on the other hand, refers to the sets of instructions or programs that allow the various hardware components to manipulate data. Programs and data are usually stored on hardware media, such as CD, DVDs, hard disks, or other drives. Although they can also be stored on other media or even embedded in computer chips. These programs are loaded into various parts of your computer hardware, such as your computer's memory and processor when you first turn on your computer and when you start additional software, such as word processors or internet browsers. For the main components of computer, the previous hardware examples are presented in this slide alongside their full definition. There are two types of programs. The first, applications, includes those programs designed for a specific use and with which you commonly interact, such as word processors, computer games, graphical manipulation programs, and computer system utilities. The second type, operating system software, consists of a series of software components used to control the hardware of computer. Turning on a computer loads the operating system into computer hardware, which then loads and centrally controls all other application software in the background. At this point, the user is free to interact with the applications, perhaps by typing on the keyboard or clicking a mouse. Applications then take the information supplied by the user and relay it to the operating system. The operating system then uses the computer hardware to carry out the requests. The relationship among users, application software, operating system software, and computer hardware is illustrated in the following slide. As seen from the slide, there are certain rules for the relationship between operating system, hardware components, and application software. Without hardware components, you would not be able to use operating system. Without an operating system, you would not be able to use your application software. and without an application software, you would not be able to perform word processing and other tasks. The operating system carries out many different tasks by interacting with many different types of computer hardware. For the operating system to accomplish this, it must contain the appropriate device driver software for every hardware device in your computer. Each device driver tells the operating system how to use that specific device. The operating system also provides a user interface, which is a program that accepts user input indicating what is to be done, forwards this input to the operating system for completion, and, after it is completed, gives the results back to the user. The user interface can be a command line prompt, in which the user types commands, or it can be a graphical user interface, which consists of menus, dialog boxes, and symbols known as icons that the user can interact with via the keyboard or the mouse. A typical Linux graphical user interface is shown in the slide. Now, after completing our discussion of the first objective, we move to the next one related to Linux operating system. Linux is an operating system that is used today to run a variety of applications on a variety of hardware. Similar to other operating systems, the Linux operating system loads into computer memory when you first power on your computer and initializes or activates all of the hardware components. Next, it loads the programs that display the interface. From within the interface, you can execute commands that tell the operating system and other applications to perform specific tasks. The operating system then uses the computer hardware to perform the tasks required by the applications. Linux has the ability to manage thousands of tasks at the same time, including allowing multiple users to access the system simultaneously. Hence, Linux is referred to as a multi-user and multitasking operating system. Similarly to other operating systems like Windows where they use the graphical user interface, the picture from the slide is an example of Linux operating system look. The core component of the Linux operating system is called the Linux kernel. The Linux kernel and supporting software, called function libraries, are written almost entirely in the C programming language, which is one of the most common languages that software developers use when creating programs. Although a variety of software can be used to modify the appearance of Linux, the underlying kernel is common to all versions of Linux. The Linux kernel is developed continuously, and, thus, it is important to understand the different version numbers of the Linux kernel to decide which kernel version is appropriate for your needs. Because the Linux kernel is directly responsible for controlling the computer's hardware, you might sometimes need to upgrade the Linux kernel after installing Linux to take advantage of new technologies or to fix problems related to your computer's hardware. Consequently, a good understanding of your system's hardware is important in deciding which kernel to use. As seen in the slide, Linux kernel versions are made up of the following three components: major number, minor number, and revision number. The major number is the number which indicates the major revision to the Linux kernel. The minor number indicates the minor revision and stability of the Linux kernel. An odd minor number indicates a developmental kernel, whereas an even minor number indicates a production kernel. Developmental kernels are not fully tested and imply instability. They are tested for vulnerabilities by people who develop Linux software. Production kernels are developmental kernels that have been thoroughly tested by several Linux developers and are declared to be stable. Revision number indicating the most current changes to the version of the particular kernel that is being released. As seen from the slide, this is an example of a Linux kernel version and the distribution of the three numbers alongside their type. Number 2 is the first number, which is considered major number. The second number is 5, indicating the minor number. Because 5 is an odd minor number, this Linux version is considered a developmental kernel. If number 5 was any other even number, 6, for example. This version would have been production kernel. Last number is the third, which corresponds to 9. It indicates how many times this version has been revised. An odd minor number indicates a developmental kernel, whereas an even minor number indicates a production kernel. Developmental kernels are not fully tested and imply instability. They are tested for vulnerabilities by people who develop Linux software. Production kernels are developmental kernels that have been thoroughly tested by several Linux developers and are declared to be stable. Companies often choose Linux as their operating system because of the rules governing Linux licensing. Unlike most other operating systems, Linux is freely developed and continuously improved by a large community of software developers. For this reason, it is referred to as open source software. The fact that Linux is an open source software operating system means that software developers can read other developers' source code, modify that source code to make the software better, and redistribute that source code to other developers who might improve it further. Like all OSS, Linux source code must be distributed free of charge, regardless of the number of modifications made to it. People who develop OSS commonly use the internet to share their source code, manage software projects, and submit comments and fixes for bugs, flaws. In this way, the internet acts as the glue that binds together Linux developers in particular and OSS developers in general. The main implications for Linux as an open source software are listed in the slide. Linux adheres to the GNU General Public License, GPL, which was developed by the Free Software Foundation, FSF. The GPL stipulates that the source code of any software published under its license must be freely available. If someone modifies that source code, that person must also redistribute that source code freely, thereby keeping the source code free forever. Another type of open source license is the artistic license, which ensures that the source code of the program is freely available, yet allows the original author of the source code some control over the changes made to it. Thus, if one developer obtains and improves the source code of a program, the original author has the right to reject those improvements. As a result of this restriction, artistic licenses are rarely used because many developers do not want to work on potentially futile projects. In addition, other types of open source licenses are available that differ only slightly from one another. There are a multitude of reasons so many people have begun using Linux. Some examples include risk reduction. Companies need software to perform mission-critical tasks, such as database tracking, internet business, and data manipulation. However, changing customer needs and market competition can cause a company to change software frequently. This can be very costly and time-consuming, but is a risk that companies must take. Linux is merely one product of open source development. Many thousands of OSS programs are in existence, and new ones are created daily by software developers worldwide. Most open source internet tools have been developed for quite some time now, and the focus in the Linux community in the past few years has been on developing application software for Linux, such as databases and office productivity suites. Almost all of this software is open source and freely available, compared with other operating systems, in which most software is closed source and costly. OSS is easy to locate on the web. Common software available for Linux includes, but is not limited to, the following: scientific and engineering software, software emulators, web servers, web browsers, and e-commerce suites, desktop productivity software, for example, word processors, presentation software, spreadsheets, graphics manipulation software, database software, and security software. Stability and security of OSS is developed by those people who have a use for it. This collaboration between several developers with a common need speeds up software creation and when bugs in the software are found by these users, bug fixes are created very quickly. Often, the users who identify the bugs can fix the problem because they have the source code, or they can provide detailed descriptions of their problems so that other developers can fix them. By contrast, customers using closed-source operating systems must rely on the operating system vendor to fix bugs. Users of closed-source operating systems must report the bug and wait for the manufacturer to develop a solution to the problem. This process takes weeks or even months. For most companies and individuals, this process is slow and costly. The thorough and collaborative open-source approach to testing software and fixing software bugs increases the stability of Linux. Security, a vital concern for most companies and individuals, is another Linux strength. Because Linux source code is freely available and publicly scrutinized, security loopholes are quickly identified and fixed, usually by several different developers. In contrast, the source code for closed-source operating systems is not released to the public for scrutiny, which means customers must rely on the vendor of that closed-source operating system to provide security. A security breach unnoticed by the vendor can easily be exploited by the wrong person. Every day, new viruses are unleashed on the Internet to infiltrate closed-source operating systems, such as Windows. By contrast, the number of viruses that can affect Linux is exceedingly low. As of April 2008, Linux had fewer than 100 known viruses, whereas Windows had more than 1 million known viruses. Most Linux systems today that run antivirus software do so because they host files that may be shared with Windows computers. Another important feature of Linux is that it can run on a variety of different computer hardware platforms frequently found in different companies. Although Linux is most commonly installed on the Intel platforms, Linux can also be installed on other types of hardware, such as the Alpha. This means that companies can run Linux on very large and expensive hardware for big tasks, such as graphics rendering or chemical molecular modeling, as well as on older hardware, such as an old Sun Ultra SBR computer, to extend its lifetime in the company. Few other operating systems run on more than 2 different hardware platforms, making Linux the ideal choice for companies that use a variety of different or specialized hardware. The ease with which you can control the inner workings of Linux is another attractive feature, particularly for companies that need their operating system to perform specialized functions. If you desire to use Linux as an Internet web server, you can simply recompile the Linux kernel to include only the support needed to be an Internet web server. This results in a much smaller and faster kernel. For those who are new to Linux, the Internet offers a world of Linux documentation. Frequently asked questions and easy-to-read instructions known as how-to documents are arranged by topic and are available to anyone. How-to documents are maintained by their authors yet are centrally collected by the Linux Documentation Project, LDP, which has over 250 websites worldwide that allow you to search or download how-to documents. Linux is less expensive than other operating systems, such as Windows, because there is no cost associated with acquiring the software. In addition, a wealth of OSs can run on a variety of hardware platforms running Linux, and a large community of developers is available to diagnose and fix bugs in a short period of time for free. However, although Linux and the Linux source code are distributed freely, implementing Linux is not cost-free. Costs include purchasing the computer hardware necessary for the computers hosting Linux, hiring people to install and maintain Linux, and training users of Linux software. Linux is based on the Unix operating system developed by Ken Thompson and Dennis Ritchie as seen from the picture. It was developed through the efforts of many people as a result of the hacker culture that formed in the 1980s. Therefore, to understand how and why Linux emerged on the operating system market, You must first understand Unix and the hacker culture, which is explained in the next slide. The term hacker refers to a person who attempts to expand his knowledge of computing through experimentation. It should not be confused with the term cracker, which refers to someone who illegally uses computers for personal benefit or to cause damage. Most hackers in the early days of Unix came from engineering or scientific backgrounds because those were the fields in which most Unix development occurred. Fundamental to hacking was the idea of sharing knowledge. A famous hacker, Richard Stallman, promoted the free sharing of ideas while he worked at the Artificial Intelligence Lab at MIT. He believed that free sharing of all knowledge in the computing industry would promote development. In the mid-1980s, Stallman formed the Free Software Foundation, FSF, to encourage free software development. This movement was quickly accepted by the academic community in universities around the world, and many university students and other hackers participated in making free software, most of which ran on Unix. As a result, the hacker culture was commonly associated with the Unix operating system. Unfortunately, Unix was not free software, and by the mid-1980s some of the collaboration seen earlier by different Unix vendors diminished and Unix development fragmented into different streams. As a result, Unix did not represent the ideals of the FSF, so Stallman founded the GNU project in 1984 to promote free development for a free operating system that was not Unix. An important feature of Linux is its versatility. Linux can provide services meeting the needs of differing companies in a variety of situations. Furthermore, configuring these services is straightforward, given the wide range of documentation freely available on the Internet. You can simply choose the services that are required and then customize Linux to provide those services. These services can be used on a local computer workstation, or you can configure a service to allow other computers to connect to it across a network. Services that are used on the local computer are referred to as workstation services, whereas services that are made available for other computers across a network are known as server services. Although thousands of different server and workstation services are available that you can use to customize Linux, configurations of Linux that are commonly used today include the following services: Internet servers, file and print servers, application servers, supercomputers, scientific workstations, and Office/personal workstations. Thank you for attending this session. Quiz information will be given to you on the WhatsApp group.